video covers section 2.5, graphing transformations. You might want to refer to page 100, which has a phenomenal summary of all of the different transformations. I think by now you know how to graph shifts, right, left, up, down, and basic x-axis reflections. So we're going to look at, I'm just going to do one problem to start as a review. Then we're going to look at maybe a couple of different y-axis reflections can be kind of tough. And then changing y values by when you multiply by a factor of a. So let's look at something like, we're just going to go for the gusto. Y equals -1/2 x plus 4 quantity squared plus, how about 2? We're going to get it all at once. What value of x makes x plus 4 0? Some of you, you should have referred to this as h. Y equals a x minus h squared plus k. H and k. And this is it's true for all your parent functions. A absolute value of x minus h plus k. Y equals a root x minus h plus k. You figure out the shift for all of your parent functions the exact same way. H is the horizontal shift, k is the vertical shift, a is your stretch, compression, and reflection. The difference between these, there's 20 of them or whatever, is what shape are you drawing? So the shift here would be left 4, up 2. This is a stretch by a factor of 1/2, and it is a reflection over x. You can plug and chug. It always works, but it is certainly not time efficient. Left 4, up 2. 1, 2, 3, 4, up 2. This is the new vertex of the parabola. This is the new vertex of the parabola. I'm going to reflect it over, and I'm going to multiply all my y values by -1/2. If you know your parent points, these graphs are going to be so much easier. So what I mean by the parent points, I will just kind of draw it in. I'm going to do a dotted sketch. 1, 1, 1, 2, 1, 2, 3, 4, 2, 4, -1, 1, -2, 4. These are your parent points. Again, you do not have to sketch the parent in. For some of you, it might be helpful. So it goes through the point 1, 1. Well, I'm going to multiply my y values by -1/2. So instead of 1, 1, this point is now 1, -1/2. Instead of 2, 2, let me write this here, 1, 1 becomes, instead of 2, 2, 2, 4, sorry, instead of 2, 4, it becomes 2, -2. I consider, when I'm graphing these, I kind of look at this new vertex, what is it, -4, 2. I kind of tend to think of that as my new origin point. One, -1/2. So from this vertex, I'm going to go through 1, -1/2, pretending that's my new origin. Pretending that -4, 2 is my new origin. Instead of going through 2, 4, now I go through 2, -2. 1, 2, 1, 2. -1, -1/2. -2, -2. Not the prettiest of graphs, but You should have at least 3 points. You should have at least 3 points. I'm going to do a quick check. I know you don't like to. Nobody likes to check their work, but let's do it. So according to my new graph that I've drawn here, one of the points is -2, 0. Another point is 1, 2, 3, 4, 5, 6, -6, 0. When I plug in -2 to the given function, I should get 0. Let's see. All right, so when I do my check, the f of -2 is -1/2 -2 plus 4 squared plus 2. So this is -1/2, -2 plus 4 is 2, squared is 4, plus 2, and last time I checked, that was indeed 0. Okay, let's look at x-axis reflections. Oh, no, sorry, that was an x-axis reflection. Let's look at a y-axis reflection. Parabolas naturally, and absolute values, they naturally have a y-axis reflection. What about a graph that doesn't naturally have a y-axis reflection? So how about a square root graph? What if I ask you to graph the f of x equals the square root of 3 minus x? Okay, so I'm going to really quickly just draw the parent square root, and then we'll take care of the shift. All right, so normally we have the parent x root x function is 1, 1, 1, 2, 3, 4, 1, 2. Okay. Ask yourself what value of x makes this 0, and the answer is positive 3. Positive 3. So this is a shift right 3. This is a shift right 3. Okay. We are going to reflect. This is the same thing as the f of x equals negative x plus 3. 3 minus x, negative x plus 3. This right here is a y-axis reflection. So I am going to reflect first. Reflect. Then shift. Okay. So when I reflect 1, 1, that becomes negative 1, 1. When I reflect 4, 2, that becomes negative 4, 2. Okay, so I'm going to take my negative 1, 1 and my negative 4, 2, and I'm going to move those right 3. So if I have negative 1, 1, that's right here, and I'm going to move that right 3. 1, 2, 3. Oh, I should have started with the origin. Sorry, the origin. Well, when you reflect 0, isn't that still 0? 1, 2, 3. When I reflect negative 4, 2, 1, 2, 3, 4, 1, 2. So when I reflect 4, 2, and it becomes negative 4, 2. So here's 4, 2 on the parent, and I reflect it over and I get negative 4, 2, and I move that right 3, 1, 2, 3. That becomes, I believe, negative 1, 2. This dotted right here was the parent. So it looks like I have 3, 0. I'm going to write down these points that we can check. 2, 1, and negative 1, 2. Those are points on my new function. All right, let's check. Well, when you plug in 3, don't you get 0? 3 minus 3 is 0. Square root of 0 is 0. When you plug in 2, 3 minus 2 is 1. Square root of 1 is 1. Plug in negative 1. Be careful. 3 minus negative 1 is 4. Square root of 4 is 2. All right, something that's new that can be kind of confusing is what happens when you have something like when the absolute value of A, sorry, I'm like not totally organized. When the absolute value of A is greater than 1, that is a compression. And A is the coefficient on the function. A is the coefficient on the function, sorry, right here. A is the coefficient on the function. And A is like outside the parentheses. A is outside the absolute value. A is outside the square root. Well, what happens when A is inside? Okay, so if the absolute value of A is greater than 1, it's a compression. If the absolute value of A is less than 1, it's a stretch. This is a compression to the y-axis, stretch from the y-axis. So what happens when you have y equals A times some function? Okay, so I did that in the first example. I believe it was 1/2, and we multiplied all the y values by 1/2. So we multiplied all the y values by 1/2. So in this case, whatever A is, some function times A. What happens when A is inside the absolute value bars? What happens when A is underneath the square root sign? We're going to multiply each x coordinate of the function by 1 over A. Huh? Okay, so let's look at the square root function. Let's just do 2x. Let's not do a shift. Let's just start slow. Okay, so the parent for a square root, 0, 0, 1, 1, 4, 2. Of course, it goes through 9, 3, and a bunch of, 16, 4, but those generally don't fit on our graph. So the square root of 2x, we're going to multiply all our x values by 1/2. So 0, 0 stays 0, 0. That's beautiful. But 1, 1 becomes 1/2 1. Two times 1/2 is 1. Square root of 1 is 1. 4, 2. 4, 2 becomes, excuse me, the x coordinate is 4. 4 times 1/2 is 2. 2, 2. And do a quick check. Well, 2 times 0 is 0. Square root of 0 is 0. 2 times a half is 1. Square root of 1 is 1. 2 times 2 is 4. Square root of 4 is 2. So this graph compared to the parent, it's going to be, the stretch compressed is going to look a little bit different. Excuse me. It's not very clean and neat. All right, I'm going to sketch the parent in just with the dotted line 0, 0, 1, 1, 1, 2, 3. Okay, there's my parent. All right, well, root 2x still goes through 0, 0, but now it's 1/2, 1, 2, 2. So it looks like such. And there you have it.